Study about Mir15a Mir16-1 cluster and its novel targeting molecules negatively regulate cardiac hypertrophy. In this study, we screened hypertrophic-associated Mirnas. We demonstrate the Mir15a Mir16-1 cluster is negatively correlated with the degree of cardiac hypertrophy in patients with HCM. Additionally, CCA80 enhancer binding protein, CEBP, beta is responsible for its down-regulation in CMIs by directly binding to its promoters. In response to pathological stimuli, the heart develops ventricular hypertrophy that progressively decompensates and leads to heart failure. Mirnas are increasingly recognized as pathogenic factors, clinically relevant biomarkers, and potential therapeutic targets. We identified that Mir15a Mir16-1 cluster was negatively correlated with hypertrophic severity in patients with hypertrophic cardiomyopathy. The Mir15a Mir16-1 expression was enriched in cardiomyocytes, CMIs, decreased in hypertrophic human hearts, and decreased in mouse hearts after transverse aortic constriction, TAC. CM-specific Mir15a Mir16-1 knockout promote cardiac hypertrophy and dysfunction after TAC. CART enhancer binding protein, CEBP, beta was responsible for the downregulation of Mir15a Mir16-1 cluster transcription. Mechanistically, Mir15a Mir16-1 cluster attenuated the insulin IGF-1 signal transduction cascade by inhibiting multiple targets, including INSA, IGF-1R, AKT3, and serum glucocorticoid-regulated KINSA1, SGK1. Prohypertrophic response induced by Mir15a Mir16-1 inhibition was abolished by knockdown of insulin receptor, INSA, insulin-like growth factor 1 receptor, IGF-1R, AKT3, or SGK1. In vivo systemic delivery of Mir15a Mir16-1 by nanoparticles inhibited the hypertrophic phenotype induced by TAC. Importantly, decreased serum Mir15a Mir16-1 levels predicted the occurrence of left ventricular hypertrophy in a cohort of patients with hypertension. Therefore, Mir15a Mir16-1 cluster is a promising therapeutic target and biomarker for cardiac hypertrophy. Nanoparticle carrying Mir15a Mir16-1 treatment decreases cardiac hypertrophy and improves cardiac function in an experimental animal model of pressure overload. Our study exhibits important clinical implications for both the treatment and prediction of cardiac hypertrophy. Mir15a Mir16-1 cluster exerts protective effects against the progression of the cardiac hypertrophy and dysfunction, left. During hypertrophic stress, increased CEBP beta downregulates the Mir15a Mir16-1 cluster, resulting in upregulation of multiple target proteins, INSA, IGF-1R, AKT3, SGK1, in cardiomyocytes, causing increased activation of insulin IGF-1 signaling, ultimately causing cardiac hypertrophy and dysfunction. The CHOPEGA delivery system replenishes Mir15a Mir16-1 in the heart, attenuating cardiac hypertrophy and heart failure, right. Meanwhile, reduced circulating Mir15a Mir16-1 levels are associated with the hypertrophic degree and cardiac hypertrophy risk in patients, bottom. Thank you for watching this video. Please subscribe our channel for watch more scientific research videos.